first of all, has been the most exciting of, it's the fifth, and it's the most exciting of all the E3S symposia that we've held. And I just wanted to share with you what I got out of the meeting very briefly. On Thursday morning, we learned that we're going to extend memory up into the third dimension. We're going to do three-dimensional integration. Basically, in the future, all memory has to be integrated with logic. I mean, the idea of having them separate is going to go away. Then we switched gears into deep learning, and boy, that was a really interesting educational experience for us. And we got an idea of all the different approaches, but I developed an appreciation, thanks to Professor Kauenbergs here, that it's very exciting now in the 2010s, but this field was kept alive for decades by people who were dedicated to drawing the analogy with the human brain. And so long before we had really good practical applications, that kept the field going. But there's an opportunity there for us device people, because you can see, well, my preference of all the different options yesterday was the crossbar resistor array. And there are so many different ways of making tunable resistors. So I think it does represent a good opportunity for us device people. And then we heard some interesting things this morning with regard to negative capacitance transistors, and great progress, as you heard from Boker's talk, 100 times speed up in magnetic switching. So that's terrific. We heard about the mechanical, nanomechanical, and nanophotonic implementations, especially the work by Stoyanovich, further extending silicon photonics. Now, regarding the tunnel FETs, I think there's still a lot of controversy. And as you know, I'm a big fan of the trap-assisted tunneling. But I ask you to think about it in a slightly different way. Suppose you had these nanowire tunnel FETs, and they're just there's some differences, because we heard about the electrostatic effects, and no two of them are going to be alike. Well, that's all that trap-assisted tunneling is. It's just a statement that no two of them will be alike. If you have one that falls at a lower threshold, if you had a whole ensemble, you'd call that one the trap. And so it gives you an indication that what's really troubling the tunnel FET field is we need to have absolutely consistent, reliable threshold. We have to be able to manufacture with a very reproducible threshold, and that threshold variation is really a representative of trap-assisted tunneling. And finally, we thank Sheikh Ahmed, and very interesting discussion. Yet another problem, that is the Auger generation. So with that, I managed to get the last word in. So let me wish you all very happy and safe travels. I will hang around a little bit if you want to complain to me.